Bentley, the crown jewel of the IGO portfolio, located 60 kilometers north of Leonora in the eastern goldfields subterrane of the Archean Yilgarn Creton. Here, 3 volcanogenic massive sulfide deposits, or VMS, occur in close proximity. The Bentley mine is located at the southernmost margin of this current VMS cluster. It is a steeply west-dipping ore body featuring a zinc sulfide-rich hanging wall zone and a copper-rich footwall or feeder zone. The current deposit supplies millions of tons of ore to the world market, making it one of the most economically significant deposits in the world today. The ore zone at Bentley features high-grade zinc-rich sphalerite interspersed with a massive chalcopyrite zone which hosts the copper. The multiple lens nature of the deposit means there are several mineable deposits within close proximity to one another. From the copper-rich Arnage stringer zone through the zinc-rich Arnage massive zone to the Molsane, which is differentiated from the Arnage by a mafic sequence of dolerite. To properly understand the formation of the Bentley deposit, we must first venture to the bottom of the ocean. Here, at the mid-Atlantic ridge, the same processes are occurring today that formed the Bentley multiple lens VMS system many millions of years ago. Hydrothermal vents known as black smokers are formed by fissures in the oceanic crust. These fissures allow superheated sulfide-rich hydrothermal fluid to be ejected into the surrounding near-freezing water, causing the sulfides to settle out on the ocean floor. Water movement within the crust brings the metal-rich sulfides from the mantle to the sea floor where, due to changes in temperature, metals drop out of solution, forming the feeder zone and the deposit itself. The feeder zone draws the copper out of solution as the temperature drops from 400 degrees down to 300 degrees as it approaches the surface into what we call the footwall or stringer zone. As the hydrothermal fluids hit the cold sea water, the temperature drops within seconds from 300 degrees down to 100 degrees and less, where the lead and zinc sulfides precipitate along with the remainder of the copper. This is what we see billowing from the majestic black smokers. This sulfide-rich layer is eventually overlain by volcanic lava flows before the process is repeated again to form another layer of sulfides. This process can continue many times, creating multiple lenses of sulfide dispersed between sediments and volcanic successions. The host rocks are then deformed and metamorphosed through regional scale orogenic events, which causes widespread tilting and folding of the ore body until it reaches its present-day position. Over time, weathering and erosion bring the deposits nearer the surface, where they can be economically mined. Here we see how the copper feeder zone forms the footwall of the Bentley deposit, while the high-grade sulfides form in the hanging wall. It is clear that the Bentley deposit is a true marvel of nature and has earned its rightful place as the jewel in the IGO crown.